Today I focused on how Climbot would stop a fall. I looked at four main systems: magnets, centrifugal brakes, torque, and ratchets. So eddy currents would be as simple as rope around a spool, and we have a magnetic system underneath it, or the eddy current system underneath it. It'll allow people to pull out the rope freely in one direction, because as you're climbing up, it's not going to be too fast and you won't experience a lot of resistance. As you fall back down, you will experience a lot more resistance. So the rope is going to be pulled out a lot more in that same direction, and so the eddy currents are going to slow you down. Going down to the centrifugal brake, we just have a spinning brake along the spool of the rope. As you're going up climbing, you're not going to be taking out the rope at a incredibly fast speed, so you're free to take out the rope. But as you're falling, the rope's going to be taken out of the system a lot faster, causing the brake to expand out and slow your fall. Now this is the more interesting one, where the rope would actually be outside of the system and not inside of the system. This would just be essentially a giant gree, but essentially rope goes inside the system, it goes outside the system, and when there is torque getting pulled on the rope from falling, it gets pinched. The last type of system that I looked at is a ratchet system. All it is a wheel that has edges on it, and there's arms on it that latch down onto each of these edges. And as you spin around the wheel, these arms prevent the wheel from going backwards. So I thought this would be really interesting to look into, because if I attach the rope to a ratchet wheel, I can allow the rope to spin out in one direction and prevent it from going back. So this is my final idea with how I can solve falling and controlled descents. It's again a centrifuge and racket, except we have either a hydraulic or a spring attached to the rope. And the reason why it's attached to the rope is because rope's tension is not always the same. Sitting down on the rope with a descent is different than falling. And if you can imagine that, it's when you're falling, there's an instant where the tension of the rope spikes. And I want to analyze that spike using a spring that is attached to the rope that will pull up, so that the spring will then activate the spall. This way, if somebody wants to descend down safely, they can, and the centrifuge will catch them. But if they slip and miss a hold, they can fall. The spring will notice the sudden tension in the rope, and the latch will activate, catching the ratchet and catching their fall.